Greetings. I have already uploaded 2 video lectures about the subject of rational function. The first one was kind of introductory, preliminary to build the core of the subject of. And then the second one, I went through example of a rational function where the polynomial in the numerator and polynomial in the denominator, they had same degree. Now, if you have not already watched them, I do encourage you to watch those videos, and I have already provided the site link of them in the comment section. So in this video, I'm going to go to review the previous lecture briefly and then complete the sketching the graph of that I did not do in the previous lecture. Okay, then let's start, shall we? Now, we know that rational function, quickly I'm reviewing that, is a function that involves with ratio. The numerator is polynomial, denominator is polynomial, and with polynomial goes degree. If so therefore we can have three kinds of rational function. One, that the degree of numerator is less than degree of denominator. The other one, degree of numerator is equal to degree of denominator. And the last one is degree of numerator is larger than degree of denominator. Now, again, I repeat myself that the previous one, the degree of numerator that we discussed with, was the same degree. The both polynomial numerator and denominator, they have same degree. Now, I selected a good example that the denominator has 2 critical points. We know what critical point means. One of them was 2, the other one was 4. And the function, the rational function at 2 and 4 has problem. Now, 2 and 4 are not in the domain of the rational function, but is not in the domain does not mean that we have to ignore it, because we are used to it. For example, if we want to sketch the graph of, let's say, y equals square root of x, where x is a non-negative real number, then the domain of that is non-negative real number. We are not concerned about negative, our concentration is on the domain of from 0 to positive. So we ignore in a sense what it is not in the domain, but in this case it's kind of exactly opposite. 2 and 4 are not in the domain of the function, but they are the critical point. They are the one that is more interesting to see the behavior of function about these 2 points. Now, I made a chart. I said that x minus 2 over x minus 2 do not cancel them. You recall that? And these 2 always, no matter what value you give to x, numerator and denominator are same, so it gives you a skinny bond. And 1 times any number is itself. So we treat this numerator and denominator that way rather than say we cancel them. Now, here 2 and 4, we noticed in the previous lecture that the function was behaving differently. Both of them are making denominator 0, that's correct, but the function behaves differently on 2 as it does in 4. At 2, the function did have limit value, whereas at 4, the function did not have limit value. You follow me? So we approached 2 from both sides, from left side and from right side. The left side I left it as a homework for you to do. I went from the right side, and we noticed how the function was behaving, and I sketched a graph for you. So let's go quickly through that graph and analyze it, and then go through to see how the graph of this function will look around what with the let's say vertical asymptote that x equals to 4 was the equation of that. Okay, let's so you already are familiar with that. Let's go through the graph of that. Now, here as you already know, again I'm repeating myself, when we approach to 4, the value of function was approaching to negative 7 over 2, which is negative 3.5. So that is there is kind of a hole in there. Now, the function as the function we approaches to 4 from left hand side, the graph of the function goes to negative infinity, goes beneath Earth and comes from the other side of the Earth out. So it goes all the way down to negative infinity when we approach to 4 from the left hand side. Now, then we want to now to analyze this graph when we go to the left now. When we go to the left, it's easy to find out where the graph will hit the y-axis. Just set for x0. When you put for x0, he tells you where where the function will hit the y-axis, a little below the negative 1. Very simple. Now, where does it hit the x-axis? Does it hit the x-axis? So, when it does the x-axis, because we are dealing with a rational function, a ratio is equal to 0. If a ratio equals to 0, denominator cannot be 0. Common sense, we cannot have division by 0. Therefore, if a fraction is equal to 0, the numerator is responsible for that. So don't go ahead and be mechanical without thinking, okay, we multiply cross product 0 times this is 0, so this odd. Try to contemplate and analyze the situation in your head and be very patient. Look at them, concentrate, and that's the beauty of mathematics. If you become mechanical and do this and follow recipe, that is the cause of anxiety for mathematics, because you are not learning mathematics. You are not learning mathematics when you do follow recipe. Unfortunately, some of the instructors also teach that way, which of course I'm myself a victim from back home, but that is beside the subject. Now here, look at what happens when he hit the x-axis. Again, I repeat myself, when he does hit the x-axis, what is the coordinate of that point? Y is 0. So when is y 0? The fraction equals 0, because y equals to fraction. When is the fraction equal to 0? The numerator is responsible, not denominator. Denominator cannot be 0. So we set the numerator equals 0. What is numerator? X minus 2, x plus 5. So when we set it equals 0, we have two zeros in that polynomial. One of them is 2, one of them is negative 5. We already investigated about 2, and we found out that 2 was not in the domain of function to begin with. So our concern is about what? About negative 5. So negative 5 is the point that the graph will hit the x-axis. Fantastic. So we know when it hits the x-axis. Now let's continue. Let's go to the left of negative 5. Negative 6, negative 10, negative 100, negative 1000, and see how the function behaves. Now look at this one. These two, I repeat myself for the 1000 times, you do not cancel them. These two give you a skinny 1. 1 times any number is itself. So you end up with x plus 5 over what? X minus 4. Now, if you look at this fraction, the x that we are selecting is to the left of negative 5. Is that right? So all of the x's that we are selecting are negative numbers. So the numerator is plus 5. So it's going to take away 5 from it. The denominator is negative 4. It's going to add negative to that, because we are selecting negative numbers. So the denominator will be larger than numerator in absolute value. The denominator will be larger. Just plug some number, though, just as I said, contemplate and plug some number. Put 100. When you put 100, negative 100. When you put negative 100, the denominator is what? Negative 104. The numerator is what? Negative 95. Numerator is a little smaller than denominator. But because both are negative, therefore the outcome is positive. X is negative, Y is positive. So where does the graph fall? The graph falls into the second quadrant. Because second quadrant is the quadrant that all the points, the x coordinate of them is negative, y-coordinate of them is positive. Now, as x gets more and more and more negative, we know that this ratio approaches what? Approaches 1. You see that? Because both are negative. But numerator is always a little bit less than denominator. So the approaches 1, but below 1. In the infinity, maybe touches 1, but because that is the definition of asymptote, looks like we have a nice looking asymptote to the left of 1, to the left of 2, as we go to the negative infinity. So now we finish with the graph of that going that way. Now let's see what happens if we go toward what? Toward 4, and then we already discussed that, but we are just kind of reviewing one more time and see how the graph of that one will look like. So we are done with this. Again, contemplate. The good part of video lecture is that you can always pause, think, and patient, and don't rush yourself, and think. Critical thinking is very important in mathematics. Mathematics is not recipe following. It's not poetry. It's a contemplating, thinking, and once you make the discoveries and see for yourself, you make conjecture. It's a fascinating subject. It makes you fly. It makes you high in reality. It's the best. I don't know what a drunk means because I've never used any alcohol, but you get drunk with mathematics in a sense, of the joy in a sense. Okay. Okay, now let me go to analyzing the graph, the graph as we go toward 4. So this graph is kind of, I have both of them, it's kind of complete graph. It's upside down, it is not. Okay, Rabbit. Let's see what we have here. So we already talked about when we approach to 4. When we approach to 4 from left-hand side, again was part of your homework, the value of the function goes to negative infinity. You can look at the equation of the rational function and see why when you approach to 4, what happens when you approach to 4 from left-hand side. Okay, now what happens when you approach to 4 from right-hand side? From right-hand side, again, you can put a small point. I've already made a chart for that. Let's say 4.00001, and you see what, when you give that one to the x, to what happens to the value of function, what kind of number comes out. You can do all of them in your head. You notice that the function is going toward infinity. It doesn't give you any value. It doesn't accumulate in certain point as we did for the 2. For the 2, the function was accumulating around what? Around the point was 2 comma negative 3.5. But that doesn't happen here. It doesn't accumulate, it just keeps going forever up. And when we look at the equation of that, let me put it up again and see what happens for this one. Now look what happens. When x was terribly big, let's pick some number for yourself. Let's start by 20, 30, and so on. When x gets very, very large, these two, do you remember, they always give you 1. So we are not concerned about that one. The numerator is always a little bit add because we are taking x to be positive. So 5 is added to that. The denominator is what? The denominator is taken 4 away. So the denominator is a little smaller than numerator. It's exactly opposite of the other side. So that means the graph of the function will approach 1 but from the top, not from the bottom, from the top of the one. Approaches 1 as what? As x approaches infinity. And when you go to terribly, terribly large, 5 and 4 has no effect. If you add 5 drops to the ocean or take 4 drops out of the ocean doesn't feel anything. You follow me? And so we know that the function will approach to 1. So that will be the complete graph of that, of the function as x approaches what? Approaches infinity from right. Now, in the next video lecture, I'm intending to to select the example that the degree of numerator of the rational fraction will be less than the degree of denominator, and then analyze that situation. But just for the sake of curiosity, I have already uploaded about this subject of inverse of function, and I encourage you to watch it in my channel. And that is, if I rotate this one 90 degrees and then reflect it about the x horizontal axis, what I get will be the inverse of this graph. So this is rotation, and that is the reflection. And look what happens. This will be the inverse of that function. I have given a full lecture for this, why it works that way, geometrically and analytically. And I do encourage you to possibly watch that one. It's very, very sweet and important to see that. Now look what happens. This is the inverse of that. And the horizontal axis now become vertical, and vertical axis become horizontal. It's very interesting. Look at that. So we know precisely how the graph of the inverse of that rational function will look like without even going through analytical approach and starting to graph. Just rotate it 90 degrees clockwise or counterclockwise, in this case clockwise, and then reflect it about the horizontal axis. What you get is the graph of the inverse of that. Okay, then I thank you very much for the opportunity, and I wish you all prosperity. And I'm repeating myself for the next one, I will be uploading a rational function that the degree of numerator will be less than degree of denominator. Okay then, so long, have a nice, prosperous day, and please stay safe. So long for the second time.